first one, we learned last week that if you have the numerator in the exponent, okay, so if I have something like this, I have exponent and then I have index. That's actually what it's called. That's the same thing where we put the index in the little cubby hole and then that numerator is going to go on the inside, right? That's what we learned last week. So for this one, we would have this guy on the inside and then this guy on the outside, right? Yeah. So this should be the cubic root of x to the 5th. Why do they even got this down here at the bottom? Because it would be negative, but they don't have it as negative, right? So it'd be false. What? On the next one, we learned last week that if we have a power raised to a power, we're going to multiply. So that's going to give me y raised to the 3/4. And then I'm going to write this out in radical form. So that would be the 4th root of y to the 3rd power. Exactly what they have here. So this is a true statement. Yeah, you multiply the exponent. Now, the last one looks really crazy, right? Now, we do have a power raised to a power. So what we're going to do first is get rid of this 1/2. So what's 64 raised to the 1/2 power? No, not divide. We take the, so we take the square root. So that's going to be 8. Okay. Now, x to the 3rd raised to the 1/2 power, that means we're going to multiply, right? That's going to be x to the 3/2. On the next one, we have y to the 4th raised to the 1/2. That's going to be y to the 2nd. In the bottom, we just have all this stuff, but we have a negative right here. So we can flip that guy to the top. So we're going to write out the rest of this. And then flip the x to the 1/2 up to the top. Say again. Well, all right, now that we're here, we can simplify a couple of things. Okay, so we can take all of my x stuff and put it together. Okay, we see that there is an x to the 3/2 in the top and an x to the 3/2 in the bottom. What can that do? Okay, cool. All right, and then we've got, okay. And then we've got y to the 2nd, y to the 5th, right? So can we subtract those? Yes. Y to the 2nd minus y to the 5th would give me y to the negative 3rd. And then we just keep that x to the 1/2, right? Well, what do we know about negative exponents? Not that they don't exist. They're bad. So they go down to the bottom, right? So this is going to be 8x to the 1/2 divided by y to the 3rd. Is that the same thing as what's written over here? No. So this is true. Am I playing the music? So on the first one, you're telling me that x would equal 2, right? Could it also be negative 2? Yes. Okay, and also looking from our graph over here, when x equals 2 and x equals negative 2, what's our y values? 4. Boom. Okay. On the next one, if we took the square root of 2, so that's going to be positive and negative square root of 2, right? Okay, so that's roughly like 1 point something, right? Boom. Okay. If I took the square root of 0, that's going to give me 0. And look at where it's crossing right here. All right, here's the tricky one. Ready? When we square root both sides, we're going to get x equals positive and negative I. Okay. Remember, this is going to be where it does not cross the x-axis. Okay, this is an imaginary solution. We learned about that a little while ago. Take a moment, write these 4 things down. About graphing radical functions. We've been talking about rational, so now we're going to talk about radical. Okay, these are the 2 words that I need you to know: square roots and cube roots. Okay, well, we're about to find out today. Okay, so on your paper, I want you to write down square root parent function. I want you to write the equation, and I want you to draw this little table, write these 5 things down, and then we're going to talk about it in just one moment. First, we're going to fill in this table. Okay, so really quick, if I took the square root of 0, what am I going to get? 0. If I took the square root of 1, what am I going to get? If I took the square root of 4, what would I get? Square root of 9? Square root of -1. I. Square root of -4. Square root of -9. Okay, so notice how you've got imaginary on the left-hand side. Like after 0, we start going imaginary, right? But our domain is going to be from 0 to positive infinity. Okay, so from 0 to positive infinity, because everything else is imaginary, right? So brackets mean that it touches it. Parentheses means that it does not touch it. Okay, so other words that you might see is inclusive, non-inclusive. Say again? Okay, so I'm going to plot these points over here on the graph so that you can see. So we got 0, 0, 1, 1, 4, 2. Oh, okay. 4, 2, and then 9, 3. Okay, so we got this graph going on. For range, we're going to have from 0 to positive infinity, because it's going to continue going up. Mm-hmm. Domain is X, range is Y. Okay. For in behavior is where does our function actually end up? So as X is going to the right, positive infinity, what's happening to our Y values? Where are they going? Well, it's going to continue going up, right? Okay, so we're going to say positive infinity. As X is going to the left, so really it's only going to hit 0, right? So we're going to say as X is approaching 0 from the right-hand side, where is our Y going to? Try again. We're moving this way. It's going to 0. So again, I need y'all to watch. Ready? Because this is the one where y'all mess up. As we move to the left, where does it end up? Well, it stops right here at 0. Okay. Now, is this increasing or is this decreasing? Increasing, and it's increasing the entire time, right? So we're going to say from our domain, which is 0 to positive infinity. On this one, though, we're going to use parentheses instead of brackets. Okay, this is one difference. Okay, and then we're not decreasing. If we take the cubic root of 0, what are we going to get? Okay. And then if we take the cubic root of 1, what are we going to get? Okay. And then if we take the cubic root of 4, we're going to get 2. Not 2. 1 something, right? Okay, so we're just going to leave that guy underneath the radical. What about the cubic root of 9? Don't say 3. It's like 2 point something, blah, 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 right? Okay, what about -1? -1. If I take the cubic root of -4, I'm going to get the cubic root of -4, whatever that is. Okay. No, we're taking the cubic root of -1. Okay. If we take the cubic root of -9, that's also going to give us some weird number, right? Now, it won't give us an imaginary because this is the cubic root. That is the difference between square and cubic. For our domain, we're going to have numbers from -infinity to positive infinity. And our range is also going to be from -infinity, positive infinity. Okay. So when I graph this, it's going to look something like this. All right. Yeah. So it's going to look something like this. A little more of a curve, but y'all know how my graphing is. As in behavior, so as we move to the right, our Y values are going to go to positive infinity. As x is moving to the left, our y values are going to negative infinity. And is this increasing or decreasing the entire time? Okay, so with increasing and decreasing, I need y'all to pay attention particularly to, like, if you start over here on a roller coaster, are you going up or down? And are you ever going down? No. Okay, so that means that it's increasing the entire time. Okay, so that's from negative infinity to positive infinity. So we're not decreasing on this guy. But when you're doing increasing and decreasing, you start from the left-hand side and you kind of just like trace the line and kind of imagine yourself, hey, am I going up or down? Yeah. Yeah. Okay. Go ahead and finish. So on your paper, what I need you to write is this equation. Okay. Because we're going to talk through what H and K are and what A is as well. Okay. So you got A square root of x minus H plus K. K is going to be where it moves up and down. Go to student.desmos.com. Okay. So H is going to be left and right. And then A is going to be a stretch or a shrink. Stretch. Yeah, like dilate. Yeah, this says stretch and shrink. Yeah, that is stretch. All right, listen. Okay. All right. Okay, so really quick, let's talk through these different things. So if I have a negative A, look at how it's moving. Look at how it's moving. What is it doing? Up or down. Not up or down. Use your geometry terminology.
It's translating. Oh, it's reflecting.
Reflecting. Okay, so it's reflecting. Okay, so A is reflecting. H is going to move left or right, and then K is going to move up or down. One thing to keep in mind is that the opposite sign of H is going to be the direction. So what I mean by that is if I have H is 1, Lord, come on. There we go. Okay, so if H is 1, when I plug it into my equation, it's going to say x minus 1. Okay, so underneath the radical is always going to be the opposite sign. Yep. Okay. All right, so on that next slide, same thing is going to happen. Okay, but you're just dealing with a cubic function. So A is still going to be dealing with stretching or shrinking or reflecting. H is going to be left or right, and K is going to be moving up or down. Okay, so same thing is going to happen on this one. You can play around with those numbers if you want. Okay, we've already talked about what those types of transformations do to it. Yeah. So if it's, let me give you the example on the next slide. Let me get there, and it might help a little bit. If you didn't get all of the different transformations, they're written out right here. Okay, so for instance, if I have a number out front that's negative, that's going to be a reflection across the x-axis and either a stretch or shrink depending on the number of A. Okay, these are all the things that we just wrote down. So you don't have to do every single one. All right, looking at slide number 5. Okay, go ahead and write this equation down. Okay, and we're going to talk through the transformations that happen. So the first thing that you notice is there's a negative out front. So what does that mean we're going to have? It's going to be reflected across the x-axis. Okay. On this next one, we got this +4. Okay, so that means that we're going to move 4 units left. Okay, so we're moving 4 units left. And this is kind of Paris, what your question was. It says +4 underneath. Normally that means right? But in this case, it's left. So that positive means left. Yeah. And then we have that -1. So -1 is going to mean moving down 1 unit. Okay. So now we're going to do the domain, the range, the end behavior, and increasing and decreasing. So what I would suggest to you, because I'm not the best grapher on this thing, is go ahead and go into Desmos graphing. And we're going to type that equation in. Okay, so looking at the equation up on the board, and we got the graph. So what's our domain going to be? What's our farthest left x value? -4. And then how far to the right does it go? Positive infinity. What about your range? What's the lowest y value? Okay, I said lowest y value. Well, it keeps going down, right? That's gonna be negative infinity to what's our highest y value? -1. So we're from negative infinity to -1. Okay. For our, is the next one in behavior? Okay. So for end behavior, as x is approaching positive infinity, what's happening to our y's? Where are they going? They're going down to negative infinity. As x is approaching -4 from the right-hand side, what's happening to our y's? They're going closer and closer to -1. Okay,